Alright, so today we're going to start section 9.3 and we're going to do right triangle trig, which I know you've done before, and we're also going to talk about some of the trig identities, some of the more important ones. We'll get into other ones later on in the next chapter. So first, right triangle trig. So if I have a right triangle, I know it's a right triangle because that's a right angle. I'm going to call this my angle theta. So everything is in reference to theta. If I move theta, that's fine. I can move theta up here, but that's going to change what I call the sides. So what do I call the sides? Well, hopefully we know opposite the right angle is the hypotenuse. Opposite the angle that we're talking about is the opposite side. Really clever, I know. And then next to the angle that we're talking about, but not the hypotenuse, is the adjacent side. Again, really clever, I know. So this leads us to something that I'm sure you've all heard before, and that is SOHCAHTOA. Now, SOHCAHTOA is a good way to remember how to evaluate the given, or how to evaluate our normal trig functions for a right triangle. Well, what does it actually mean? Well, what it's telling us is that the sine of theta, and again I'm just sticking with theta, is going to be opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. The tangent of theta is opposite over adjacent. The cosecant of theta is hypotenuse over opposite. The secant of theta is hypotenuse over adjacent. And the cotangent of theta is adjacent over opposite. So this is what we really need to know for our right triangle trig. So now let's do an example. So if I tell you that the secant of theta is 6/5, I want you to find the remaining trig functions. Alright, well, what do we want to do first? Well, let's draw a picture. So I'm going to draw a right triangle. I get to choose where theta can go. I can put theta down here, or I can put theta up here. It doesn't matter. Once I choose, though, then it's going to matter how I label the sides. So if I put theta down here, now I want to start labeling the sides. Well, I know secant is hypotenuse over adjacent. So this side is 6, this side is 5. Well, what's this other side, the opposite, going to be? Well, let's see, if I do the Pythagorean theorem, 5 squared plus, let's call it x squared equals 6 squared. So this is going to become the square root of 11. Alright, now I can find my other trig functions. The sine of theta is going to be what? Sine is opposite over hypotenuse. The cosine of theta is going to be adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant is going to be hypotenuse over opposite, so 6 over root 11. We want to rationalize. And then what's the last one we need to do is cotangent. So cotangent of theta is 5 over root 11. Again, we'll rationalize. So those are the remaining trig functions. Alright, now we're going to get to our 11 trig identities that we want to memorize. So first we're going to talk about the reciprocal identities. There are 6 reciprocal identities. Well, we need to make sure we understand what is a reciprocal. And remember, a reciprocal is similar to a multiplicative inverse. So what is going to make this 1 if I multiply it by something? So the reciprocal of 2 is 1/2. The reciprocal of 3/4 is 4/3. Okay, good. We've all got that. So what is the reciprocal of sine of theta? It's going to be 1 over the cosecant of theta. If I understand this, then I know the cosecant of theta is 1 over the sine of theta. So if you know one, you know the other. the cosine of theta is 1 over the secant of theta. And again, if I know that, then I know the secant of theta is 1 over the cosine of theta. And then the last two, hopefully, are kind of obvious. The tangent of theta is 1 over the cotangent of theta. And the cotangent of theta is 1 over the tangent of theta. So we need to memorize these, we need to know these, we don't even want to have to think about it, we want to just know it. Now, one thing to point out, if you know 3 of them, you know the other 3, so you don't actually have to memorize all 6. You just need to know which 3 to memorize. Also, the tangent and cotangent one, that one makes sense. A lot of people get confused with the sine goes with cosecant versus cosine goes with secant. We'll understand that a little bit later on when we learn cofunction identities. But for now, you're just going to have to understand that sine goes with cosecant as far as reciprocal, and cosine goes with secant as far as reciprocal. Alright, the next 2 identities that we want to make sure we understand are the quotient identities. Well, first of all, what does quotient mean? Well, when we're using quotient, or when we say quotient, think back to our last chapter. What was it? It was the result of division. So I know division is going to take place here. Well, now how does sine, cosine, and tangent relate to the coordinates on the unit circle? Well, we know that sine of theta is y, cosine of theta is x, and tangent of theta is y over x. But wait, if tangent is y over x, what is that actually telling me? That's telling me that it is sine of theta over cosine of theta. So that right there is the first of our 2 quotient identities. So our quotient identities say tangent of theta is sine of theta over cosine of theta. And then the other one has to do with the reciprocal. So what's the reciprocal of tangent? It's cotangent. So the cotangent of theta then is the reciprocal, which is cosine of theta over sine of theta. So if we know one of these and we understand their reciprocals, then we know the other. So again, it's not about memorization. The more you understand the relationships, the better off you are. Think about also the right triangle trig, the SOHCAHTOA. Tangents opposite over adjacent, cotangents adjacent over opposite. So they all directly relate. These are not unique things that we're learning for. Alright, well now let's talk about the Pythagorean identity. So these are the last 3. So first, what is our Pythagorean theorem? Well, hopefully remember it's a squared plus b squared equals c squared. We've been doing that for a while. Okay, well how does sine, cosine relate to the sides of a triangle? Well, I know that sine is going to be opposite over hypotenuse, and cosine is adjacent over hypotenuse. Alright, so let's look at a right triangle. So if I have a right triangle, let's call this theta. So this is my opposite, this is my adjacent, and this is my hypotenuse. Let's rewrite our Pythagorean theorem, but in terms of those. So I know that this is opposite squared plus adjacent squared equals hypotenuse squared. Well, what if I take this equation, but I divide everything by hypotenuse squared? So now this would become opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared equals 1. This leads us to our first Pythagorean identity. So the first Pythagorean identity is going to be sine squared of theta plus cosine squared of theta equals 1. This is the most important one. If you understand and know this, you can easily come up with the other 2. There's 2 ways in which we can do that. One, we can go back to what I did up here. So with my Pythagorean theorem, but written in terms of opposite, adjacent, and hypotenuse, what if instead I divide everything by opposite squared? So if I divide everything by opposite squared, this will become 1 plus adjacent squared over opposite squared equals hypotenuse squared over opposite squared. Well, if I write that in terms of trig functions, then that gives me my other Pythagorean identity. The other way to think about it is taking this first identity and dividing everything by sine squared. So my other Pythagorean identity is going to be 1 plus cotangent squared theta equals cosecant squared theta. Okay, well now the third Pythagorean identity comes from same idea. Let's go back up here, but now instead of dividing everything by opposite squared, let's divide everything by adjacent squared. So then I'm going to end up with opposite squared over adjacent squared plus 1 equals hypotenuse squared over adjacent squared. So again, this is the way to think about it in terms of the sides of a triangle. In terms of trig functions, if I take sine squared theta plus cosine squared theta equals 1, and I divide this whole equation by cosine squared theta, that will lead me to my third Pythagorean identity, which will be tan squared theta plus 1 equals secant squared theta. So these are my three Pythagorean identities. Again, you do not need to memorize them necessarily. You need to understand where they come from. They come from the Pythagorean theorem. Also, one other thing to point out real quick, I believe I talked about this at the beginning of the year, but I'm not sure, so I'll refresh your memory, and that is notation. When we're dealing with trig functions, sine squared theta is the same thing as sine of theta quantity squared. It is not the same thing as sine of theta squared. So we want to make sure we understand that notation. If we are going to type this into the calculator, we have to type it in like that. Okay, so now let's see an example using the Pythagorean identities. So if I give you that the sine of theta is 3/4 and theta is acute, find the secant of theta using the Pythagorean identity. So I want you to pause the video and come back when you think you got your answer. Alright, hopefully you got that the secant of theta was 4√7/7. If you didn't, or if you're confused, I'll show you how I did my work. So I used the Pythagorean identity, sine squared plus cosine squared equals 1. Sine is 3/4, so 3/4 squared plus cosine squared of theta equals 1. 3/4 squared is 9/16. 1 minus 9/16 is 7/16. And then I took the square root. Now, one thing to note, when I took the square root, notice I didn't do plus or minus. Well, why didn't I do plus or minus? And that is because we were told that theta is acute. Therefore, I'm in the first quadrant, and therefore I know that the secant of theta is going to be positive. So then the secant is the reciprocal of cosine, so it's 4√7/7. Alright, there's one more set of identities I want to look at, and one more example I want to do, but we'll save that for part 2 just so we don't run out of time. But just to recap also, the Pythagorean, the quotient, and the reciprocal identities are the main 11 that I referred to at the beginning of the video that you need to know for sure. All the other identities are very important as well, but those are super important, let's say.